Good afternoon, everybody. And it's really my pleasure to introduce this keynote speech because the keynote speaker, Reda is my old friend. We met in 2009 in Athens, Greece, for the first Aslan conference. And now the Aslan conference has become the top tier conference in research area of social networks. And Reda is the founder of and now is the chair of the Aslan conference. So I think he is a leader of, one of the leaders, of this research area, social network and data management. So I just have a brief introduction, of the Reda Alhajj. He is a professor in the Department of Computer Science at the University of Calgary in Canada, and published 450 papers, in journals and conferences. And now he is also a founder and the editor-in-chief of the Springer Journal, Social Network Analysis and Mining, and also book series in Springer, Nature Notes on Social Networks, and also editor-in-chief of Springer Journal, Network Modeling Analysis in Health Informatics and Bioinformatics, and also edited a book called Encryptpedia on Social Network Analysis Mining. So I think if you want to get to know somebody of social network, you should know Reda first. All right. So his research area is mainly on many areas. The first one is data management and mining, and the second one is social network analysis with application in computational biology and bioinformatics, homeland security, and sequence analysis with the emphasis on domain like financial, weather, traffic, energy, and also XML schema integration and re-engineering. So I think you probably will learn a lot from his keynote speech, and let's welcome Professor Reda Alhajj. So let's welcome him.
Thank you for the introduction and thank you for inviting me here. It's my pleasure to be here the second time. I have been here before 2011 for Asuna, and the organizers did fantastic work 2011, and this year it's a very fantastic conference. Thank you again. So, switch the slides from here. So today I will talk about how we can use limited computing resources in order to analyze big data, because the computing resources are not growing as fast as the data that we have. And not everyone can afford having big computers in order to analyze data. So we need to be able to provide some techniques to allow people to analyze big data using limited resources. So big data as a buzzword, as the morning speaker said, the data that we are collecting is growing very fast. And it's expected that we will have almost 45 times more data in 2020 than what we had in 2009. But the definition of big data differs from person to person, from community to community, and there is no yet agreement on what is big data, because what I could agree on as big data today may not be big data tomorrow. So this is like a moving target. Always we have more data collected, and whether we are able to process the data or not, this is the key thing to say whether we have big data or not. So, mostly they say that big data is something that we cannot handle using our existing computing resources. So, in the past, we were only using databases in order to collect data and store and retrieve data. Then the machine learning community and data mining community started to develop some techniques for knowledge discovery in the data, and we started to realize the importance of the data, though we are still lagging behind in discovering all the details that are hidden in the data. So the data is a gold mine, and we need more techniques, more sophisticated techniques to mine from the data, to discover from the data. And as I said before, big data has been in place for a long time because it depends on who and in what era you are living. For example, VLDP is the very large database conference. This started in 1975. 41 years ago, they called it Very Large Database Conference because at that time, databases were assumed to be large. So, but if we look at big data, there are three main bottlenecks that we have to deal with. The storage space is one bottleneck, the processing power is another bottleneck, and the network bandwidth is the third bottleneck. Because we cannot transfer the big data from one side to another to process the big data at another side. It's more convenient to transfer the algorithms, the programs from one side to another, process the data locally, and get the results summarized. And this problem has been handled in database community by optimizing queries, distributed queries, in order not to transfer the whole data from one side to another. So query processing has been tackling this problem for a long time. So we can utilize some of the old techniques in order to deal with big data. As the morning speaker said, incremental data management has been around for a long time, but now they realize the need for incremental techniques, and thanks to the morning speaker that he made good introduction to what I will talk about, because I will talk about many incremental techniques that we have to do. So big data is characterized by 4 V's: the volume, the velocity, the variety, and the veracity. So the most important of these is the velocity, because the others are there for a long time. Because we cannot talk about data or database without maintaining the integrity and maintain the trust in the data. So if we lose the integrity of the data, whether it is big or small, the data is useless. The volume of the data increases, and it has been increases slowly in the past. Now with the development in technology, we are getting more volume, and the velocity of the data is increasing. So the velocity is the most important, because we have more techniques, more devices to collect data, so we are collecting larger volumes of data, so we have to handle these larger volumes of data. The variety of the data has been dealt with since the 80s. For example, those who are in the database area already know that the object-oriented databases evolved because relational databases were first normal form, were only handling simple types, and then object-oriented databases were developed to handle more complex types. But later on, relational database industry absorbed all the object-oriented characteristics, and object-oriented databases almost died in North America and Europe. Some research is still going on object-oriented databases. But as I said, the most important is the database velocity. So, today I will try to talk about some of the techniques that we have developed in order to deal with big data. I will start with a quick overview of my research group, my involvements and achievements that we have done, a quick overview of the data mining techniques that I will refer to, and then I will talk about scalable data mining techniques, because the data is available incrementally and we need to be able to handle big data incrementally. And then, because we have online databases and we have web databases, it's no more that only professional users can access the database. So we should provide some user-centric interfaces for databases. We should allow the user to speak to the database the way he or she wants, the way he or she understands the database. So two different users may raise the same query database. Everyone should get his or her own answer the way he or she understands the database. I will talk about some applications in social networks and network analysis in general, and I will describe some of the tools that we have developed because we do some applied research and we develop some tools in order to use in our research. So I have a large group of students working in different aspects of data analysis and data sciences. We participate in many competitions. The Microsoft Imagine Cup, we get 2 awards in 2004, 2003. And the code competition, the Canadian government opened the government data for research and allowed people to use the data, and they wanted to get the best benefit of the data. We participated and we get one of the top 15 teams out of over 900 teams. I am running a lot of services, including ASONAM, which is Tier 1 conference in social network analysis and mining. The next year it will be in California in 2016 in August, mostly third week of August. You are welcome to submit. The acceptance rate is always below 20%. And I am involved in the IRI, Information Reuse and Integration. It is in Pennsylvania next year, but not known yet, should be in August. Encyclopedia of Social Network Analysis and Mining was a major project that we did over the last 4 years. And it is the most accessible encyclopedia by Springer. We are preparing now for the second version. We only accept submissions by invitation. We invite authors to submit. And we have the lecture note series for which we accept book proposals. If you have in mind any book on social network analysis and mining, you are welcome to submit a proposal. You may edit some papers from conference, extended versions, or your own lecture notes from a course, and we can publish that. And I have the Social Network Analysis and Mining Journal, which has been added to ISI Expanded Index in September this year. So it is covered now by ISI Expanded Index. It is Tier 1 journal in this area. We have a very strong editorial board for this journal. And we run the summer school on social network analysis and mining. The first one was in Greece in 2014. We decided to run it every 2 years because we try to find sponsors in order to minimize the cost on the participating students. So 2016 it will be in Turkey. We have not specified the time yet. So as I said, we work on all aspects of data mining and data analysis. We have applications in bioinformatics, in stock market analysis, in terror analysis, criminal analysis. So various aspects of data sciences are covered by our research. We have collaboration with industry because we try to solve real-world problems in different aspects. So all our research is based on network analysis and data mining. So a network is a set of nodes connected by links. Based on who is accessing this network, who's utilizing this network, you give semantics to the network. So from computer network perspective, the nodes are computers and they are linked together. From sociology perspective, they are humans. From biology perspective, they are genes or proteins and molecules. So you can build a network. After you build the network, you give semantics, and then you analyze based on that. Data mining techniques were developed long time ago, but in the 90s with Agrawal developing the a priori algorithm for frequent pattern mining, the data mining community start to evolve rapidly, and we have now many top-tier data mining conferences. So for those who don't have background in data mining, the a priori algorithm is very simple. Given any set of transactions, like samples here, and the molecules that are expressed in every sample form one row, we can analyze this data to find which molecules are mostly expressed together in most of the samples. So we find first the singletons and the frequency of each singleton in the database. Then we keep only the frequent singletons. Then we form pairs out of the frequent singletons. We scan database again. We find the frequency. We keep only the frequent pairs. Then we scan database again, and we find the frequency of the triplets until we find all the frequent item sets. So this is very important in analyzing the correlation between items in any domain where you have many-to-many relationship between two sets of entities. Clustering is another data mining technique where you group together objects that are similar. So there are different types of clustering algorithms. Some clustering algorithms force every object in one cluster. You don't get very good clusters. Some algorithms allow objects that don't belong to any cluster to stay outside as outliers, and then you have very compact clusters. Classification is another data mining technique where you try to build a model to guess a target class based on characteristics of the objects that you have. So based on the outlook temperature and humidity, I want to decide whether it is good to play outside or not. So I try to inspire and learn from the data a model that will allow me to predict based on some future data whether I can play outside or not. So if we look at data mining approaches that were developed in the 90s, then you will find out that many of them are based on unrealistic assumption that you have unlimited amount of memory, and they test based on this assumption. If you put them in practice, they will not work beyond the main memory. So we have limited main memory, we have huge data, and we want to analyze the huge data using the limited memory. So what we have here, we have two characteristics of the data that we need to deal with. We have dynamic data that is incrementally available. For example, if you get a retail store, every day you get new transactions. You cannot rebuild your model from scratch every time. You have to do incremental analysis. And you have also large data. So one of the techniques that was developed and very attractive for frequent pattern mining is the FB3, FB growth. This has been attractive because there are two scans of the database. The first scan, you scan the database, and you try to find the frequency of each item. And then you sort the database based on the frequency so that the frequent becomes the first element of each transaction. And then you build a tree from the sorted frequent database. Then the tree is built in a compact way such that near the root you have the more frequent items, and near the leaves you have the less frequent items. So it is a compact tree. It summarizes database. You have minimum number of children for each level because you sorted each transaction by itself. Now, but this works good for static databases. If we modify the database, then we have to run the algorithm from scratch. If the database size grows, this will not be efficient. So we have to avoid from scratch computation. So we developed a technique that allows us to incrementally build the database and analyze by only considering the incremental component added to the database. So we developed 3 operations that can be applied on the tree. First, we have to find which nodes have to change their position. We apply these 3 operations, the pull, split, and merge, in order to restructure the tree. So, if, let's say, this node N becomes more frequent than node P, then we have to swap them, we pull N up. If node N becomes more frequent than P, but N has some siblings, then we have to split P first so that N becomes the only child of this component so that we can swap them and the other siblings become the children of the other component. Or if we get 2 nodes which are siblings, then we have, and they contain the same item, then we can merge them into one node and combine their children. So this works very well in incremental mining of frequent patterns. So if we have this database, we added this new components to the database, new transactions, then we can analyze the database, find out that after we add these new ones, then M becomes the most frequent because its frequency now is 6. It has to go up to the top. So we find M in the tree, we have to pull M up. So we pull each M up, and then the second M, we pull it up, so that it becomes the direct child of the root. Then we merge the 2 M's because they are the same level. Then if we look again, we have the F, the C, and the A should be merged because they are siblings. Then after we get the tree ready to absorb the new part of the database, now we can add the new part of the database. And then we have the updated tree without any need to build the tree from scratch. Now, providing for incremental construction of the tree is not enough. Because the main memory is limited, we may get large data and we may not be able to analyze the whole data using the main memory. Even the virtual memory management system provided by the operating system will not help us. So, for this, we developed a new technique. But the FD growth, what they did, they ordered the transactions horizontally. That is, each transaction is sorted. What we did is we added another order by ordering the transactions alphabetically. So that the smallest transaction alphabetically comes first. This way will allow me to build the tree from left to right, top down. So after I finish constructing this part of the tree and move to the right, I will never get any transactions that will be added on the left. Because my transactions are ordered alphabetical order, so always the tree grows to the right side. So when I need more memory, I can throw on the disk all the left side. I keep in the memory only the right side, which will grow. So now, the limit of my processing power is the disk, not the memory. So for this, we had to rewrite some components of the operating system, and we have to develop our operating system that is capable of doing frequent pattern mining with limited memory. So we developed 4 heuristics for this. We had to put all items that are to be accessed together very close on the disk, so that they can be retrieved together. We have to bring into memory any item that is to be processed, and when this is brought into memory, we have to process it for every prediction we need. We have to minimize the refetching of the items from disk into memory. So every time we get some items into the memory, we exhaust their utilization so that we minimize their bringing back again. In order not to lose too much, we applied recently used in order to replace items in the memory. And we used R3 structure in order to build our different data structures that we have in order to be able to analyze. Now, using this technique, we can analyze large databases. So if we have a small database, this is the memory that we have. This is the size of memory required to analyze the database. For a small database, we can use part of the memory and it's okay. But as the database size grows, then we go beyond the memory. We cannot process the whole data using the main memory. So we need to go to disk. So if we use our technique, then a main memory-based FB3 will only handle this much of the database. But our technique will handle the whole database of 400 megabytes. Using 64 megabytes of memory, I can process 400 megabytes of memory. Now, we run tests for larger databases. So as you see, as the support value decreases, the amount of disk required to store the extra data structure increases because we produce more frequent patterns. So we need to expand beyond the main memory. Now, after developing this frequent pattern mining technique that handles big data, we also developed a technique that handles big data for clustering. So for this, we use multi-objective optimization in order to find the number of clusters. But the basic thing here, if we do multi-objective optimization, we get alternative solutions along the Pareto-optimal front. So every one of these solutions is an acceptable solution. For example, if you have a decision to buy a computer, you cannot afford to satisfy all your needs because you have limited amount of money. You want high-speed computer, top of the line, but you cannot get top of the line computer with limited amount of money. So you have multiple objectives to satisfy. So you get the different alternative solutions and you have to pick from those based on your choices. So if we go to clustering, after analyzing all these, we found out that every solution has some good clusters and some less good clusters, let's say. So we went further, I will not describe this, and we accumulated all the good clusters and tried to analyze them and find out whether they can form a solution by themselves. And we went further and we find outliers, we find fuzzy clustering out of this, so this was another research that we did. But here we found the number of solutions and we found an appropriate solution. Now, we use this for clustering big data. What we did, we partitioned the data into small partitions such that each one can be accessed and processed in the main memory. We cluster each partition alone, then we get the centroids from each clustering, and we partition the centroids again, cluster the centroids. We do this hierarchically until we get the whole data clustered then every point, every object that we have joins the final cluster where each centroid is in. Because we start with the object, we cluster the objects, then we get centroids, we cluster the centroids at each second level, then we merge the clusters based on where the centroids end, and we get the cluster. Now, if we get data available incrementally, what we do, we build a classifier from the clusters, because every cluster now by itself is a class. We know that we have 5 clusters, 10 clusters, we can build a classifier into 5 classes or 10 classes, and then the new data coming will be classified into one of the classes that we have. If we get some new data misclassified, then we keep these misclassified data in order to adjust the classifier, incrementally adjust the classifier later on, periodically or incrementally, depending on how we can adapt this, because we can have either immediate update for the classifier, or periodic update, or deferred update. We found out that deferred update is the most logical because we don't update except if we want to use the classifier. So we applied this on big data. We duplicated the band data. Those who know the band data, the band data is a database for handwritten pen characters. We duplicated this in order to get a big data, and we tried to classify this using our technique. And we applied cluster validity indices in order to find which number of clusters is the best. Because every cluster validity index will give you a ranking of the clusters that you get along the Pareto optimal front. So, now, as I said, we have naive users who want to access databases online. And every user has his own understanding, his way of thinking. We don't want to force everyone to use a high-level query language. So what we did is we added an independent layer between the database and the user to absorb all the understanding of the user. There was huge work on fuzzy databases in the 90s and late 80s. But fuzzy databases died because they tried to impose fuzziness inside the database. So I tried to force everyone to think the way I am thinking. If I think it's hot in Taiwan today, I want everyone to think that it's hot in Taiwan today. If I think that it is not cold in Canada, I force everyone to think that it's not cold in Canada. So everyone has his own understanding of these fuzzy terms. So everyone should get his own answer when he queries the database using fuzzy terms. So we allow everyone to define his own understanding. We have 3 ways of specifying the fuzzy understanding of the terms. We allow the user to specify his own understanding. We derive this automatically from the system. Because we have the data, we try to analyze the data and find the best possible understanding like this. So we derive very well distributed fuzzy sets. Our system concentrates on triangular fuzzy sets. And then we allow the user to play with the base of the fuzzy sets. He may shrink them or expand them. So we may allow manual definition, or semi-automated definition, or fully automated definition means that we find the fuzzy sets. And even we allow users to say that my understanding is similar to this group. We apply social network here so that we group the users, and users might declare similarity of understanding based on the groups that we have. As I said, what we did, we added a fuzzy layer that will allow the database to stay as it is, the user to think as he or she thinks, and all the understanding is absorbed here. This communicates with the database to get the values, based on the understanding and delivers the result to the user as it is required. So we developed this as a tool. We call it Ask Fuzzy. So the user can raise queries in fuzzy terms, and our system will take the fuzzy terms and will execute the query in SQL or OQL for object-oriented, or XQL, XQuery for XML, and then we retrieve the result. So we allow in the back end, if you go back here, we allow in the back end any kind of database, because we don't want to restrict to relational database. So our system talks to each database separately, gets the result, combines the result, return it to the user. So we have done this using the Virx system. We have our own developed Virx system. We developed this first as a tool to allow users, students, to learn XML. When XML was very popular and started to gain popularity in the database community, we developed this to teach students in our database class how to learn XML. So given any database, they can specify what fields they want to transfer to XML, and it will develop the XML schema for them. So we added the fuzzy layer into the XML, and the back end of the Virx can be any database, and the interface for Virx looks like this. So you can specify what tables you need, what columns you need, and you can nest them by dragging them inside each other. This is department. Inside department we have employee, we have works in, we have project. So we have 4 levels of nesting here, and we can specify predicates, and we can specify fuzzy predicates, like the age of the employee is young. And based on my understanding of young, this gets transformed into an SQL statement or an XQuery statement, and then these get executed and they get the answer back to the user. But because the users are mostly interested in the same query again and again, there was a huge work on materialized views in the 90s. So we reused the materialized views here. In order to materialize the view, you have to keep the view updated as the database is updated. You cannot miss the consistency between the view and the database. Every time the database is updated, the view must be updated. So, as I said, there are 3 ways to update the database. So database views get updated either immediately or periodically or increment or deferred update. We apply deferred update because we modify the view when it is to be used. So assume that we define this view in the database. That is, we need the student with tags nested inside the student. We need student taking some courses, and we need the professors. So we need the information about the students taking courses and the professors of the students. So this is my database. What we do here, we add to each table a modification list to keep the log of the changes to the database since the views have been created or modified. So as we keep log, in order to recover from any errors in the database, we keep log here in order to reflect only the important updates to the database, to the views from the database. So in the log that we keep, we call it modification list. We keep one modification tuple for each view defined. In the modification tuple, we keep what has been inserted in database after this view has been added, what has been deleted, what has been updated. So, assume we have 2 tables here, and we define a view. Then, after we define the view, we start to modify the database. view have been added to database. So now we updated something in the student table. So it is added to the last modification tuple here. Then something gets deleted from the database, from the text table. It is added to the last tuple here. Because this view, when it is updated, it takes all the union of the updates from its location up to the end of the list. Every view marks from where I will start the update. So this starts its update from here to the end. This starts update from here to the end. So something gets modified. So I defined a new view. I added M4. So now I get the last view defined is view 2, and I have too many modifications in the database. Now I need to access this view. I apply deferred update. So when I access this view, I go and find what needs to be reflected into the view. I have, this is the view to be modified. So I take everything, the union from its location to the end, I reflect this on the database. So I take that, I move those that have been reflected database to the previous instance so that they can be utilized by the previous ones. Then I am done. Now, if I can modify the views incrementally, I should be able also to modify the schema incrementally. When they developed object-oriented databases, one of the main attractions of object-oriented databases was the schema evolution, because relational databases does not allow schema evolution. But with the recent growth in the ways we collect and utilize data, always we may need to expand the database by new fields, new tables, because we don't know what data we will get. So we should allow for schema evolution. So our Virix model allows us to add tables, remove tables, add columns, remove columns, rename some columns. So we have provided all this in the database. So now let me go and describe some of the techniques that we developed based on network in order to utilize them for certain applications. Now, for databases, we have two main problems that we always have to deal with. The allocation of the tables, because some tables are mostly accessed together, we need to allocate them close together so that we can retrieve them together if they are to be utilized. And in distributed databases, we need to partition the data so that we can put partitions that are to be accessed together in the same server. So database allocation and partitioning are very important. We can utilize network analysis in order to do this by utilizing queries and tables that we have. So if we have a given set of queries and a given set of tables, every query accesses certain tables. So some queries require more than one table, some query requires one table, and so on. So we can derive a network from this, and we can analyze the network to find what tables are mostly accessed together. We can utilize frequent pattern mining in order to find sets of tables that are frequently accessed together. If we get the tables as items, and every query as a transaction, then every table accessed in the query is like an item in the transaction. So this transaction derived from this query contains two tables, means that this is like a transaction with two items. So in my database, I have 3 items. So I can map my database and the queries into a structure that can be processed using frequent pattern mining in order to find tables that are frequently accessed together. let me go over an example where we utilize the set of tables from Al-Masri and Nevada book. So given these tables and the 15 queries that we have in Al-Masri and Nevada book, so every query accesses certain tables. So if we apply frequent pattern mining with minimum support equal to, we get, these are the sets of tables that are frequently accessed together. There is overlap between them, of course. So, for example, employee, works in and project are mostly accessed together. The works in and project accessed together very frequent. So we get which tables are accessed together frequently. We can derive a kind of fuzzy score out of this frequency measure by dividing every frequency of a set by the sum of the frequencies of all the sets where works in exists. So the fuzzy membership of works in this set, let's say, equals 2 over 2 plus 5 plus 7. So we can get a fuzzy membership function and we can find a fuzzy membership score for each table. This will help us in allocating tables if we want more than one occurrence or we need a single occurrence of the table. If we allow duplication or replicate the database for faster access, for availability of the data, to increase the availability of the data, so we can have more one copy of the project, let's say, more than one copy of the works in. But if we want only one copy, we keep the copy with the highest score that we have here. So we can either have no replication and we keep everyone which have the highest score, we remove all the other occurrences of works in and keep only this. If something remains by its own, we move it to where it has the next highest score. If we need replicas, let's say, if we need at most 3 replicas, we keep the works in replicas that have the highest scores. So 1, 2, and 3. These 3 have the highest scores. We remove all the rest. We can build a network from the result of the frequent pattern mining. So a link between 2 tables shows in how many frequent sets they exist together. Then we can analyze this and find the communities of tables from here in order to find tables that should be allocated together. We can find different network analysis measures in order to find what are the important tables. For example, from here we can find that employee is the most important table. It should maybe I should keep employee very accessible because it has the highest score in terms of degree, closeness, betweenness, and so on. So we can partition the graph and find that we have 2 clusters. We use betweenness clustering. We find the betweenness centrality of the edges, and we remove the edge with the highest betweenness centrality. We keep removing edges with highest betweenness centrality until we get the number of clusters that we want. We run on different data sets with different sizes, and we reported different results. So we showed the scalability of our technique by running on 50 tables. So very huge database. And we could find very interesting communities out of these, which tables should be put together to be retrieved together if one of them is to be accessed. Now, we did another social network analysis project for the RBC, Royal Bank of Canada, where they wanted us to analyze the social media in order to find the reaction of their customers to certain advertisements by RBC. So for this project, we have a set of postings P related to topic X, which are published during a certain interval of time. We want to find how the interest in topic X is reflected in the postings by the different customers of RPC. For this, we use different social media platforms. We try to extract data from different sources related to RPC. Actually, they did an advertisement. If you transfer your mortgage to RPC, you get these benefits. And they want to analyze how this affects their customers, how the customers reacted to this. So there were postings on Facebook, Twitter, Google, and so on and so forth. So we tried to analyze this, and we tried to find the social network between the different customers based on the mutual information to see how customers group together and influence each other. And we try to find the relationship between the different topics to find what is the most important topic that has been discussed. So I will reflect here some results based on tweets that we collected, because I cannot disclose all the results because this is very confidential information for the bank. We have to get permission to use some part of the data. So we analyzed the tweets that we collected, and we clustered the customers. We find 20 different communities of customers that are discussing different interests related to the advertisement that they had. And we tried to analyze what are the basic tweets that were shared and discussed by the customers. First, we found what are the keywords by each community. And then these are some sample tweets that were discussed. Now, to do all this research, we developed different techniques and different tools. NextDriller is a tool that allows you to analyze social network. You don't need to give the network ready. If you give your data as a two-dimensional table, let's say many-to-many relationship between any data, it will extract the relationships from the data using data mining techniques. It finds frequent patterns, and based on frequent patterns, it finds which items are existing in the same frequent pattern together and derives the network based on that. It applies clustering, and it finds which instances coexist in the same cluster. It clusters the data using multi-objective clustering, and remember, we get alternative solutions. In how many alternative solutions the two items coexisted. This gives the score of the link between the two items. So it allows you also to specify some fuzziness for deriving the scores. So you can get the network from the data by utilizing data mining techniques, and this will allow you to analyze the data and to find communities in the data, to find different characteristics of the network. We developed another data-intensive application that we developed is Sano for watching health indicators of your body, because we have many people sitting in the offices these days. We inspired this actually from a real case. I collaborate with Turkey, and in Turkey they have technology parks inside the universities, like in North America, I don't know, in Taiwan. So one student, 22 years old student, passed away heart attack because he stayed almost 20 hours sitting behind the computer working to catch a deadline. So you cannot sit without exercising. So we got some data, we collected some data and analyzed the data and find how different health indicators affect your body. And when you need to practice for different parts of body. So we watch your health indicators and we indicate what part of your body. You see here the red, you get some reminder that you have to practice your neck. You have to do exercise for your shoulder. You have to do exercise for your legs. You have to do something in order to keep yourself healthy and fit. So now in Canada we have too many immigrants. When immigrants came into Canada, they want to find what is the best community for them to live and not to live the cultural shock. Because many people move from Asia, Middle East, Africa to North America, they get a culture shock. They don't know how the culture works in North America. So if you go to a community where there are many Taiwanese, let's say, you will feel like at home until you get used to the environment. So we get data from Statistics Canada, we analyze the data and we try to find out, based on your data you enter here, suggest to you in Canada which city, which community is the best for you to live in. We developed another technique for shopping based on your preferences, whether you want to save money, whether you want to save gas, the environment, whether you want to save your time, give you the best route, the best location where you can go shopping. So we optimize data that we collect from traffic, from retail stores, because some retail stores may trick you. They put some items on sale and increase the prices of other items that you mostly purchase together with those on sale, and they get more money from you. So we try to optimize and find what is the best store for you to optimize your overall spending. You may find some items on sale in one store, but if you purchase them from another store, paying maybe little more on those items, but on the overall, by saving on other items, you pay less in the overall bill. So this is an extension of the first one. This tells you if some of your friends are shopping at the same mall where you are. By capturing their location, we have the system tells your family members, if you allow, that you are at the store, they may add to your shopping list, and you may purchase something that your kids or your wife want without calling them and notifying them. Only communication between the mobile phones. Your friends even may add to your shopping list if you allow them to know that you are in the shopping mall, and they may ask you to buy something for them. So this communicates with the different mobile phones and finds things. So we did another technique for stock market analysis using different external factors and internal factors. So we use social media, we use historical stock prices, the traditional media, and we try to find what different factors affected the stock market at different eras, and try to learn from those and try to predict how the stock market will function based on the current state compared to the previous states. We did another technique that will collect data from different sources, and we can collect data from social media, from traditional data sets, and then we transform the data and reprocess the data to make it all homogeneous, and then we derive the network from the data. And we allow you to process the data and find different discoveries in the data. So, to wrap up, we are working on different aspects of data sciences with very different applications. In bioinformatics, we work on health informatics, remote monitoring. For example, in Canada, we have the two-stage healthcare system. You go to the general practitioner, and the general practitioner will send you to the specialist. In US, you go to specialists directly because you pay, or insurance company pay. But in Canada, we have the government pays, so you cannot go to specialists except if you are in need for the specialist. So we developed a technique for referral optimization because there is a long wait. Specialists are limited and too many patients. Sometimes you have to wait 1 year to see a specialist. So we optimize the wait time based on big data analysis collected over years and to see what is the best thing. So we work on security analysis, terror network analysis, criminal analysis with the Intelligence Service of Canada. So we have demonstrated in our research that we can utilize different data mining network analysis techniques in order to analyze big data. We can use limited computing resources to analyze the data. Because the data is growing faster than the computing resources, we cannot guarantee that we will afford storage for the data that will be collected in the future. So we have to optimize the utilization of the storage and the computing resources equally. So this is the end of my talk, and I'll be happy to answer any questions.
Okay, thank you for your speech. And any questions? Yes.
Thank you, Doctor, about your presentation and about the knowledge what you have delivered for us. My question about the project what you have done with the, I think called RCB Bank, Royal Canada Bank. You said you analyzed the data from the social media. I need to know how you get the classification from that data. I mean, some data was in the positive way and other data was in the negative way.
For this, we do sentiment analysis and we do opinion mining in order to find who are positive and who are negative. So this is some pre-processing of the data in order to find how people are affecting each other. We did something else other than this, is that we try to find what are the negative opinions on the internet and what are the positive opinions, and try to find the timestamp for each one and how the negative trend evolved or the positive trend evolved, and who are the influential people who influenced the negative trend or the positive trend. So we try to do sentiment analysis to find whether the posting is positive or negative. And if it is positive, we try to find out when the positive trend started to increase and who are the influential people who influence this positive trend. Because I may give a comment which is positive and you agree with me and the other agree with you. So I will be the most influential who influenced indirectly all the others.
Thank you so much.
So when you talk about data partitioning and allocation, you mentioned the term transaction. And I don't remember that. This transaction, in this table, the transaction. So I'm going to kind of take that keyword. And so a lot of the work you're presenting today is, for example, the schema have evolution. It's basically changing, and then there's a new data coming in, and we keep doing that. So in some sense, when from the transaction perspective, we have a lot of rewrite transaction that's happening. And I want to get a group of people, their discussion, there's one transaction I know that this is something which is happening, is consistent. Of course, that the traditional asset property is not going to work for this kind of so dynamic. I give you an example. You have some new event happening, and then I have some kind of rewrite transaction happening concurrently. But those things doesn't need to go into the database. Either you can wait, and for me to do that. So I'm wondering, are you aware of any works that try to look at this from the transaction perspective to analyze the data, especially in social media, that will keep adding comments, there was a new data coming in, and then Facebook is really busy with a two-stage process in order to do a real-time perspective and more back-end perspective. So what's your take about? Because I think that's kind of related to a lot of things you talk about today.
Yes, actually, the transaction that I talked about for the queries is different than the transaction from the database perspective, which is a piece of code. So here the transaction is a transaction in frequent pattern mining where you have the items. Transaction is the set of items that are processed or accessed together. So now, if you want to go to the transaction from database perspective, the traditional transaction, they say that it must have the acid property, that it should be atomic, consistent, isolated, and durable. But now, the most important is to have the database consistent when you access the database. You care about database integrity and consistency when you access database. So if your transactions will modify the database at different stages without anybody accessing the database, then you don't need to reflect the modifications on the database until you get to a stable state, except if somebody accesses in between. So you can defer your modifications, your transaction commit to the stage where you have the database to be accessed.
Understand that.
Yeah.
But on the other hand, that might be too restricted. That kind of slow down a lot of things.
Because a lot of things, maybe I'm saying something, I try to make a decision, and there's somebody on the other side is actually making some comments about what we're doing right now. But there is what I call a delay tolerant perspective, means that, yes, I include all this new input into my current analysis that might help 0.1%, but I have to do all this computation. I mean, your work has improved that process dramatically, but I sometimes want to explore different alternative route. I say, okay, I have a quick way to decide whether I should include this new piece of information inside my intelligence analysis, and maybe I can get 80% of my answer correctly, but then I'm doing this a lot faster. And so that's just, it's a thought.
No, this is very, very related to distributed concurrency control, because you have different users, all of them are trying to access the same database at the same time. So you have to organize and manage their access database, their update database. So at one piece of time, the database should be consistent before it is processed by some users, because before it's accessed and queried by some users. So some of these updates will be neglected at one point. So when you process the database, you get the database result based on a timestamp that is related to the time you access. All the others might be waiting for their transactions to be committed. You cannot, so you cannot say that I will wait until everyone commit, because it is a dynamic environment and everyone tries to process. Every time everyone tries to access and put some information in the database. So you have to say that at this point, this is the database, this is the correct answer, this is the most up-to-date, most right answer at this time. When I deliver the answer to you, it might be old, because until I deliver because if we go back, anyways, so yeah, we can talk offline, but I have to send to the database, get the answer from database. Until I deliver the answer to you, the database already has been updated. So the answer is valid at the time I get it from the database, not at the time that you saw it.
Okay, thank you. Is there any question? We can have one more question. Yes, please.
So, thank you for the very interesting talk. I'm also very interested in social network mining. One issue we usually encounter is when we study social network, usually, for example, for classification, usually the ground truth information is very difficult to get. Then in your experience, how to address this issue in research?
For the ground truth, we depend, in our research, we depend on experts. So it is very subjective, I know, but we depend on expert opinion, and we assume that whatever the experts will accept, this is our ground truth, and we try to compare our results with the expert opinion, which will differ from expert to expert, but an expert-based model we have.
Thank you for Professor Reda, his keynote speech, and let's give him an applause. Yeah. Thank you so much. I would like to present some appreciation award and a gift for Professor Reda.
Ladies and gentlemen, sorry I'm here again, and my job is keep the whole program move smoothly and keep on time as good as possible. So there's something I'd like to remind you about the following program. And actually we are a little behind the schedule, so I think the next 3 panel sessions will begin on 4 o'clock, or 3 o'clock, sorry, 3 o'clock. And 2 will be on the conference center, the panel session D1 and the D2. And at this place, we will hold the Tarzan thesis presentation. They are the thesis award recipients. They will present their thesis in this place, so you maybe can stay here and continue to listen to their presentation. And after that, we have 2 more panel sessions. One will be held in room 101 in conference center there, and another will be the Tarzan member meeting. So if you are a member of Tarzan, please move to this place to attend the member meeting. And thank you. And the last and most important is, don't forget the conference banquet tonight. It will be held just in my right hand side next to this room, the banquet hall 1. And we will begin on 6 p.m. and hope to see all of you. Thank you very much.